A gallery of 30 Industrial Revolution. The Industrial Revolution, usually dated from around the mid-18th century to the mid-19th century, brought an extraordinary array of inventions that changed industry and society alike. Most inventions were collaborative affairs where inventors built on the ideas of others. In addition, there was a continuous evolution of these inventions as inventors and engineers sought improvements in efficiency and capacity. Many inventors were often driven by a passion for their idea and the good might do rather than a mere search for profit. A surprising number made little or no money from their inventions, either because they spent all they had on research and development or because others disregarded patents and copied their ideas. In this gallery, we showcase 30 of the most important inventions, selected for how they changed and, in many cases, continue to affect everyday life around the world. Rely upon it. Locomotives shall not be cowardly given up. I will fight for them until the last. They are worthy of a conflict. Robert Stephenson, a model of the pedal bicycle invented by the Scottish blacksmith Kirkpatrick Macmillan, 1812 to 1878. In 1839, there have been earlier two-wheel vehicles, but these were not powered by turning the pedals with one's feet. Macmillan's bicycle had no gears, so the rear wheel was made slightly larger than the front wheel. The famous penny farthing bicycle, popular from the 1870s, took this idea even further and had a significant difference in size between the two wheels. Bicycles soon became popular and allowed people of modest means to travel further than they could otherwise. Donkin tin can. A Donkin tin can. The commercially viable tin can that preserved food was invented in 1811 by Brian Donkin, 1768 to 1855. Donkin built on the ideas of others to perfect a cheap and safe canning process. The idea was that soldiers, mariners, and explorers could take a food supply anywhere. Donkin ran his canning factory in London from 1813, the Donkin Hall and Gamble Company. The cans were expensive and heavy. The lightest was 2 kilograms for 0.4 pounds, and needed to be opened using special tools. But they were used by both the military and polar explorers with success to preserve soup, meat, and vegetables. Papermaking machine. As with many inventions during the Industrial Revolution, the papermaking machine was something of a collaborative affair. This model is one of the early machines developed by the Frenchman Nicolas Louis Robert, 1761 to 1828. In 1799, the machine was further developed by John Gamble in England, who then collaborated with Henry, 1766 to 1854, and Seely Fordrinier, 1773 to 1847. This trio commissioned the engineer John Hall to build an improved papermaking machine, who, in turn, enlisted the help of his brother-in-law, Brian Donkin, 1768 to 1855. By 1803, the end result of collaboration was a machine that greatly speeded up paper production, a task previously done by hand, and, by saving on labor costs, it reduced the cost of books to make them more affordable to more people. The machine took a diluted pulp of linen pieces and water and spread them upon a mesh barrel. Water drained off, and then the mash was placed between 2 layers of felt and pressed firmly between 2 rollers. Lawnmower advertisement. View full-size image. A 19th century advertisement for a lawnmower. The lawnmower was invented by Edwin Buddy in England in 1830. The machine replaced the much slower and more expensive process of cutting grass by hand using a scythe. Budding was inspired by the rotary blades used in the textile industry. The machine was popular with gardeners and those who managed sports fields, making a cut lawn an affordable reality for many more people. The machine has evolved, but budding's essential design is still used today in many models. House sewing machine. An illustration of the lock-stitch sewing machine, invented in 1844 by Elias Howe, 1819 to 1867, in Cambridge, USA. The machine made much stronger fabrics than previously, as the stitches did not unravel if the thread broke. The secret was a lock stitch where 2 threads were put into the cloth, one from below and one from above. The machine was far quicker than a person sewing by hand. 640 stitches per minute compared to the average of 23 by hand. The machine was successfully copied by such manufacturers as I.M. Singer, Davy lamp. A Davy lamp, a safety lamp designed by Humphrey Davy, 1778 to 1820. In 1815 for coal miners. The lamp's flame could not escape the mesh, and so did not set alight dangerous gases in mine shafts. In addition, a gauge could tell a miner if such gases had built up to dangerous levels since they reduce a flame inside. The safety lamp saved many lives, and miners became dependent on it. Shropshire Iron Bridge. The world's first cast iron bridge, built across the River Severn in Shropshire, England by Abraham Darby III, 1750 to 89. It was completed in 1779 and opened to the public on New Year's Day, 1781. The design had to be a single-span arch to allow shipping to pass underneath. The bridge used some 385 tons of iron. The project showed that iron could be used for such large projects, and many more followed during the Industrial Revolution. The bridge is listed by UNESCO as a World Heritage Site. Stephenson's rocket. The rocket locomotive steam engine was designed in 1829 by Robert Stephenson, 1803 to 1859, during the Industrial Revolution. The locomotive won the 1829 Rainhill Trials, and so was used to pull passenger carriages on the world's first intercity line between Liverpool and Manchester. Rocket included many new design features, such as a multi-tubular boiler and a blast pipe that gave more power than rival locomotives. The success of the Liverpool-Manchester service led to railways expanding across Britain. Macadamized Road. A photograph of a macadamized road taken in the 1850s. The macadamized road, that is, a hard and relatively smooth road surface made using 2 layers of stones, one aggregate layer and a top layer of very small stones, was first made on a stretch of road near Bristol. The surface technique was invented by the Scotsman John Loudon Macadam, 1756 to 1836. In 1816, the idea quickly caught on and greatly improved the lifespan of roads and the comfort of the travelers using them. The first coal-gas street lighting. An 1809 engraving by Thomas Rowlandson from an original drawing by Woodward showing the public's reaction to the first coal-gas street lighting in Pall Mall, London in 1807. The new lights were invented by Frederick Albert Windsor, 1763 to 1830, and the idea was a winner. By around 1820, London had 40,000 gas street lights. The Crystal Palace, a detailed and contemporary print showing the Crystal Palace in Hyde Park, London, which hosted the Great Exhibition from May to October in 1851. The innovative structure was designed by Sir Joseph Paxton, 1801 to 1865, and created almost 1 million square feet, 93,000 square meters, of exhibition space. The building used 500,000 sheets of glass and 4,500 tons of iron. The use of prefabricated parts for a temporary building on such a grand scale inspired architects thereafter, such as the Renkioi Hospital, designed by Isambard Kingdom Brunel, 1806 to 59. Early hypodermic syringe. A hypodermic syringe made by Coxeter and son of London C., 1860. Syringes were used in antiquity, but the true hypodermic syringe for injecting precisely measured liquids using a hollow needle was invented by the Scotsman Alexander Wood, 1817 to 1884. In 1853, according to tradition, Wood was inspired to create his instrument after considering how a bee stings its victim. The instrument was primarily used to administer morphine for pain relief. Horse-powered threshing machine. A French illustration of a horse-powered threshing machine. This machine, used to separate grain from the husk, was invented in 1787 by the Scotsman Andrew Meikle, 1719 to 1811. The machine used a drum with beaters to remove the husk, first using horse or water power and then steam power. It greatly increased the speed at which grain could be threshed. George Washington, 1732 to 1799, ordered a Meikle threshing machine for his own farm. Cement silo. Portland Cement Silos in Washington, USA. Portland cement was a fast-setting cement invented in 1824 by the Yorkshireman Joseph Aston, 1778 to 1859. Aston created cement through experimentation when he discovered that a heated mixture of limestone and clay could be cooled and powdered. When water was added to the powder, the concrete set very quickly. He named it Portland in reference to the esteemed stone of that name from Dorset. Portland cement was exceptionally strong, and so became popular with builders and construction companies worldwide. Bessemer Converter, Sheffield. a Bessemer converter in the Science Museum, Sheffield, England. Henry Bessemer, 1813 to 1898, invented a converter in 1856 during the Industrial Revolution that made steel production much cheaper and more reliable. Steel was much stronger, lighter, and more malleable than iron, making it the preferred choice of engineers for large projects like bridge building and laying railway tracks. The converter removed impurities from the pig iron by forcing air under high pressure to the molten metal. A larger converter could make up to 30 tons of steel in 20 to 30 minutes. Whitney's cotton gin. A cotton gin machine invented by Eli Whitney, 1765 to 1825. In the United States in 1794, during the Industrial Revolution, the machine was used to clean raw cotton and separate it from sticky seeds by pulling the cotton balls through a comb mesh and mechanism of revolving metal teeth and hooks. The machine greatly speeded up cotton production for spinning machines, since a single cotton gin could process up to 25 kilograms, 55 pounds, of cotton every day. Another consequence was the increased use of slaves to pick sufficient cotton to feed the gins. William Sturgeon's electromagnet, a replica of the electromagnet invented by the Canadian engineer William Sturgeon, 1783 to 1850. Sturgeon first devised the electromagnet in 1825. This version was invented around 1832. It was used to create a magnetic force that could provide lift and then drive a motor, making it useful for all sorts of electrical machines. SS Great Eastern. An illustration by Charles Parsons showing the steam-powered SS Great Eastern. It was designed by Isambard Kingdom Brunel, 1806 to 1859, and completed in 1858. It was the largest ship in the world at 211 meters, 692 feet, long. Great Eastern could carry 4,000 passengers and 418 members of crew. In addition, the ship could transport around 3,000 tons of cargo. The ship made its maiden voyage from Liverpool to New York in June 1860. Not until RMS Lusitania in 1906 would a bigger ship than Great Eastern sail the seas. Harrison's H5 marine chronometer. The H5 marine chronometer, designed and built by the English clockmaker John Harrison, 1693 to 1776. This was the last in the series of chronometers Harrison made for mariners to better measure longitude and so define their position at sea. Harrison's chronometer was extremely accurate. In tests it lost just 1/3 of a second per day. Silver with a white enamel face. Made in 1770. Spinning Jenny Chemnitz. A model of a spinning jenny. The machine was invented in Lancashire in 1765 by James Hargreaves, 1720 to 1778. The machine, jenny, was capable of spinning multiple threads simultaneously and was one of the first important inventions in the textile industry in the British Industrial Revolution. According to tradition, Hargreaves was inspired by seeing a spinning wheel laid on its side after having fallen over. The spinning jenny replaced the spinning wheel and greatly increased cotton thread production. Crompton's spinning mule. Samuel Crompton invented the spinning mule in 1779, which greatly increased the speed of spinning yarn for textile production. It made finer and more uniform yarn than previous machines and had many more spindles, up to 1,320. The invention was a huge success, and by the 1790s, they were steam-powered. In Lancashire, the heart of Britain's textile production, factories contained 50 million mule spindles, power looms in a textile mill, an 1835 engraving by J. Tingle, from an illustration by T. Allen, of power looms in a textile mill during the Industrial Revolution. The power loom weaving machine was invented by Edmund Cartwright, 1743 to 1823. In 1785, the machine doubled the speed of cloth production and meant that skilled hand weavers were no longer needed. The power loom was further developed by inventors like Richard Roberts, 1789 to 1864. By 1835, there were 50,000 power looms in use in Britain. The earliest photograph by Niepce. The oldest surviving photograph, taken by Joseph Nicephore Niepce, 1765 to 1833, in 1826 using a camera obscura. The photograph, then known as a heliograph, is titled View from the Window at La Gras. Neep's innovation was to permanently capture the image projected through the lens onto light-sensitive silver chloride-coated paper. Watt and Boulton steam engine. A Watt and Boulton steam engine, one of the key innovations of the Industrial Revolution, dating to 1788. This example is the oldest original rotative steam engine in the world. Designed and built by James Watt, 1736 to 1819, and Matthew Boulton, 1728 to 1809. The engine used far less fuel than earlier models created by other inventors, and so could be used almost anywhere to power factory and agricultural machines of all kinds. Milling machine. The milling machine was once thought to have been invented by Eli Whitney, already famous for his cotton gins, see 1818. But as with many other inventions of the Industrial Revolution, the truth may be more complex regarding who invented what and when. This 19th century milling machine was made in Manchester, England. Machines like this were used to cut and pierce metal into a desired form. For example, nuts for bolts. The machine allowed pieces to be made that were almost impossible to do by hand cutting. And so it revolutionized manufacturing in all areas of production. Tunneling shield. An illustration of the tunneling shield designed by Mark Isambard Brunel, 1769 to 1849. The shield was used during construction of the Thames Tunnel, completed in 1843. The shield allowed workers to excavate, but be protected from cave-ins. The idea, according to tradition, was inspired by the shipworm, Teredo novalis, which burrows into the wooden hulls of ships. The shipworm's soft interior is protected while it bores by a hard outer shell around its gnawing jaws and head. Brunel's idea was that a shield would act as a temporary support for a stretch of the excavated area until a more solid covering of the tunnel could be put in place. The tunneling shield has been used on many major engineering projects ever since, notably the Channel Tunnel connecting the UK with France. Naismith steam hammer. An 1871 oil painting of a steam hammer invented by the Scotsman James Naismith, 1808 to 1890. In 1839, during the Industrial Revolution, the steam power machine lowered a weight onto an anvil, using gears which allowed for both precision and speed. The steam hammer allowed very large metal pieces to be forged and uniformly shaped, essential for large engineering projects like the construction of weapons, bridges, trains, and ships. Painted by the inventor himself. The first telegraph machine. The first telegraph machine, invented in 1837 by William Fothergill Cooke, 1806 to 79, and Charles Wheatstone, 1802 to 1875. The machine had only 20 letters, indicating the message sent by the slight movement of 2 needles from a machine set of 5 towards a particular letter. The needles were moved by electrical impulses sent down the telegraph line connecting 2 machines. The telegraph was first used for messages for workers on railway lines, but the idea soon caught on, and people could eventually send private telegrams across continents. Goodyear vulcanized rubber. An advertisement for Goodyear rubber tires from 1920. Vulcanized rubber was invented by Charles Goodyear, 1800 to 60, in the United States in 1839 and patented in 1844. Rubber had long been used for its flexibility and softness, but Goodyear devised a way to increase its resistance to low and high temperatures by heating the rubber and adding sulfur. Vulcanized rubber was used to produce life jackets, erasers, balls, and hard-wearing tires, amongst many other items still manufactured today. Difference engine. The difference engine was invented by the Englishman Charles Babbage, 1791 to 1871, in 1822. This example is a modern model of Babbage's Mark II, designed c. 1848. Like most other inventions of the Industrial Revolution, Babbage built on the ideas of others to create a machine that was, in effect, the first complex computer. Babbage designed his machine to calculate mathematical functions and print the results in the form of tables. The machine worked by hand cranking, and Babbage was seriously hampered by the lack of technology to make the parts he really needed. Nevertheless, the machine could handle 31-digit numbers, and it showed the way forward as a new method of performing mathematical calculations too complex for humans to perform without the risk of making errors.